Welcome to Test Prep Central. We're working in Calculator Workshop number 10, Residuals. The first example says to use lists to calculate and analyze residuals for these linear data. So the first thing I'm going to do is to clear my memory. Second plus 7, 1, 2. And then I will go to my list, stat, enter, and type the data into list 1 and list 2. In list 1, we will type the values in that are listed next to the X. So these are your X quantities. Arrow right to go to list 2 and type in the values for Y. Remember when typing data to take your time, to double check, and if you can't find your mistakes, what I've discovered is have another person look at it and they usually spot it right away. I don't know why that is. But it's real easy to make a calculation or just a typo when you're doing this. I just did make one right there, -4.3. So take your time, double check, because you're going to be doing quite a bit with this data and you don't want to have an error in it and have to start over. All right, once your data is in, we're next going to generate a linear regression equation. Type second mode to go to your home screen. Type stat, calc, 4, and enter 5 times to generate a linear regression equation. You will note in this screen that the R value, which is the correlation coefficient, is not showing, which means I need to turn on my stat diagnostics if I want to see that value. So I will do that. Type the mode button and use your down arrow. And where you see stat diagnostics off, you will highlight on and then enter to turn them on. Second mode will take you back out to your home screen. If you'll type second enter, it'll retype your linear regression, or actually you could just type enter and it will recalculate your linear regression equation, and you'll see that on your screen. This correlation coefficient is 0.995, which is almost 1, so that's telling you that this data is actually very linear. This model is an excellent fit to these data. So now we're going to copy and paste the regression equation into our y equals, because we do need to calculate our residuals. That is, we're not just determining if the model is a good fit, but we're actually going to look at the residuals for the model. So go ahead and type in y equals and then put your regression equation here, and we're going to cut and paste it. So type VARS, go right to YVARS, and then type, oh, excuse me, I did that wrong again. Go to VARS, type 5, go right to EQ, and then type 1, and that will paste your regression equation in your function grapher. All right, now we're going to go back to our table or our list. So type stat, enter, and in list 3, we're going to put the values, our predicted values. And to do predicted values, you use the regression equation. So highlight list 3. Let's use the regression equation by typing variables, y variables, 1, 1. At the bottom of your screen, you'll see the y1. You'll open parentheses, and you're going to input these x values into this y1. And the way you do that is you type second 1, which is list 1, and then close your parentheses. When you press enter, it's going to take all those values, plug it into that regression equation, and put the output in list 3. And there they are. And these are your predicted values. Okay, the next step is to actually calculate the residuals themselves. So go over 1 to list 4 and up and highlight L4. Residuals are actual values minus predicted values. So we're going to take list 2, which were your actual function or your y values, and list 3, which were your predicted values, and subtract them to get our residual values, and those will appear in list 4. So type second 2 minus second 3 and enter, and these are your residuals. Note all of these are small, close to 0, and that's what we like to see. Okay, now to see the graph of the residuals, we need to turn on our stat plots and adjust our window. So type second y equals, enter, enter. We do want to have a scatter plot, and we do want our x list to be list 1, but we do not want our y list to be list 2. So let's arrow down to list 2 and type second 4, and that will put list 4, which is where our residuals are. I'm going to leave the same mark and this color. If you're on an older calculator, the color is not an option. You'll just be able to use the marks to distinguish between multiple graphs. All right, let's go over to the window button and press that. Now notice the x values are tiny. So we're going to go from a -3 to a +4 and count by ones. The y values are even smaller. Now in your handout, I went from -1 to +1, so I will go ahead and use the same numbers. But you could have gone from -0.5 to 0.5 because the numbers are actually that small. The scale I used 0.1, not 0.1. Let's go back. You could do 0.2 if you'd like. All right, when you type graph, you should see your residual values graphed. Notice on the handout you do have grid lines. I don't have grid lines. If you would like grid lines on, you can go to second zoom and go down to the third row to the right and highlight your grid lines. And then when you press graph, those will appear. They're not really necessary. You have enough information without them, but some students prefer to leave them on, and I am one of those people. I like to leave mine on. The residuals are actually showing you this model is a very good fit to the data, and this is how you know. The residual values are all close to the 0. The x-axis represents 0. So all of these points are close to the x-axis. The points are randomly scattered above and below the x-axis. There is no obvious curve or shape to this data. So that's a good thing. And that's what we're looking for in a residual model, for a model that's a good fit to the data. Let's go to example 2 and let's do a new model. So I'm going to go back to stat enter. And I'm going to clear list 4. Notice I'm typing clear enter, not delete. And I'm going to clear list 2. But in list 1, you may notice all of the numbers except for the last number are the same. So I'm just going to type delete right on top of that 3, and now my list 1 is correct. That's my new X list for example 2. For list 2, go ahead and type in your data points. Okay, and next we're going to use the equation that we are given in our example. We do not generate a linear regression equation. We use the model given, which is y is equal to 2x minus 3. So let's go over to L3. Instead of typing the function into our y equals, you could do that. You actually can just evaluate it right here by typing 2. And instead of x, we're going to put second 1 and then minus 3. And what that will do is it will take the L1 and replace it with each of these values one at a time. And then it'll output the values into list 3. So this is just another way to evaluate a function. All right, so we have our predicted values using the model given. Now we want our residuals. Same thing. Go over to list 4. And highlight the L4. Subtract your actual values, list 2, so that's second 2, and subtract from that your predicted values. That was list 3. So list 2 minus list 3. Once you've got that, type enter. It will put in your residual values. Okay, the next step in this problem is to graph your residuals. Well, I've already got my second y equals enter on. I've already got list 1 and list 4, so that is pretty much the same. The window, however, is very different. These residuals are definitely larger. The x-min is -3. I can change my x-max to +3, but for my residuals, you'll notice I'm using a much larger window because one of these residuals is 16. So if you'll go from -1 up to 16, that should be all right. Now the scale should not be 0.1. I used a scale of 1 in your handout. All right, when you type graph, you will see your residual graph. Now this is actually showing you, oh, and I look at what I just did. I cut off that top point. So let's go back and make that 16, 17 like I should have. Okay, that looks better. This looks like your handout. This model is not showing a good fit to the data, and this is why. You notice that the data points, most of them are not that close to 0. 0 would be on the x-axis. So these data points over here are very far from 0. There is a definite pattern in the data. It is decreasing only. You'll also notice they're all on top of the x-axis. They should be evenly spaced above and below the x-axis. So this is a terrible fit. We would say this is not a good fit to these data. If we calculate a regression equation, the correlation coefficient is probably closer to 0 than it is to 1. But we're not asked to do that, so we won't. But just so you know, this is not a good residual graph for a model that's a good fit. Let's go on to example number 3. Calculate and analyze residuals using both linear and quadratic models. So if you'll go back to your stat enter, you will notice that your list 1 is the same. So I'm not going to do anything to list 1, but I will go ahead and clear list 2, 3, and 4. Notice I'm highlighting the list name, and then I'm typing clear enter, and that will clear it, clear enter, like that. All right, for your Y list, which is your list 2, type in your data values. All right, once the data values are in, we're ready to generate a regression equation. So this part is the same as example 1. Let's go to second mode, and we're going to type stat, calc, linear regression, which is 4, and then we'll enter 5 times. Okay, notice the correlation coefficient here is showing you a 0.09. That's really bad. Anything close to 1 is excellent, or close to -1 is excellent, but anything close to 0 is not good. It's not a good fit. So this is telling me already that this is not a good fit to these data. Now we don't have to copy and paste this equation, which is interesting because we're going to use a feature that really is only available on the newest model calculator. And I'll show you in a minute. If you don't see what I'm about to show you in your calculator, you'll need to go back and use the method that was given to you in example 1 to do this problem. But you'll like this method if you have this calculator because it does save time. Let's go ahead and type stat enter. And in list 3, we're going to actually put the residuals for that linear model in list 3. Now, we've just calculated our linear regression equation. It's very important that you do that first and then go to list 3. And then all you have to type is second stat 7. Do you see where it says resid? That means residuals. What this will do, and I'm not going to hit enter yet, is going to give me the residuals for the linear regression equation that I just generated, and it will use the values in list 1 to do it. And it will compare it to the list 2. It basically is doing all those steps we did earlier all at once without you even having to type the actual and the predicted or the predicted values at all. So watch this. When I type enter, those are the residuals for that linear model. And that's all you had to do. Now to get the residuals for the quadratic model, which is the next step, I need to go out of here, second mode, and I need to generate another regression equation using the same list 1 and 2. So we're going to do stat, calc, quadratic, which is 5, and then enter. Okay, now this is my model for my quadratic. So I'm going to go over here and I'm going to go to my stat enter. Go to your list 4. Go up and highlight list 4. Now in list 4, I'm going to put my quadratic residuals. So since I've just generated my quadratic equation, when I do second stat 7, it's going to put residual down here. It's going to, when I enter, it's going to give me the residual values for the quadratic. Okay, now we're going to plot both of these on one graph. So let's go to second y equals. The first plot should be list 1, list 3. So let's modify that. Type enter. It still says on. X is list 1. Y is list, we don't want 4. Let's do second 3. The mark, I'm going to leave that. All right, so now let's go to second y equals 2. And let's press enter to turn this one on. Arrow down and let's make this list, this y list, list 4. This is my quadratic residuals. So let's go to second 4 to make our y list 4. Now on the older model calculators, you definitely want to change your mark. If you're on the newer model, you don't really have to because you have 2 different colors so you can tell these apart. But I'm going to go ahead and change my mark to show you that you do need to change your mark on the older model. So let's make that one a plus sign. Now I like to go back and double check because some reason these sometimes gets changed. There's a bug in the TI-83 plus CE at least, where these sometimes switch back to L2 or L4, like this will switch back, but it looks like everything looks great here. So let's go to the window and let's set the window to fit these new data. So in this case, -3 to 3 works great. The Y values though, I should make those smaller. So let's make this Y min -4. These are my residuals and they were all between -4 and 4. With a scale of 1, that should work. Now my grid lines are still turned on, so when I hit graph, I'm seeing my 2 graphs. Now you may notice this line down here. That's that y equals that we had in there earlier. So if you'll go over here to your y equals and clear that out, that will get rid of that extra graph. So that happens a lot. Now do you see how these little plus signs are super close to 0? They're all close to the x-axis. They're randomly spaced above and below. So this one is a good model. That's telling you that the quadratic graph is a good model. But look at the linear model. That was the one that was the blue one, or the one we did first. For those of you in the older calculators, the one with the square marks, of course. But this is a terrible model. This is not a good fit. And that's because the points are they have a definite curve to them. You can see a curve in the graph, and you can also see that they're much further away from the 0 from the x-axis. So that's telling you the linear model's not a good fit, but the quadratic model is an excellent fit. Okay, and that's the last one I had for you. Now in your practice exercises, you may notice I did put one that's not in your example, and that's an exponential model, but I did give you the keystrokes. It's stat calc 0 enter to get that equation. So it doesn't work any different than the others. It's just a different type of function, but I just wanted you to try something with an exponential as well. This is definitely one of the longer and more challenging workshops because it's brand new material for most students, but I do encourage you to keep going, keep practicing. The best way to master Your calculator is to practice, practice, practice. So until we meet again, continue to practice.